Hi guys, welcome to the last set of notes for this semester with Mr. Robeson, AP Statistics. So we're going to look at geometric distribution, geometric probabilities, and geometric mean and standard deviation. All right, so what is a geometric distribution? Well, it's very similar to a binomial. It'll look just like binomial, except we're looking for the first time a success occurs. So remember, we have successes and failures when we're working with binomial. Those are our two options. All right, now we won't have n trials. We're looking for our first success. So instead of bins, we could say we have BIFs. So it needs to be binary, two options. They need to be independent trials. We're looking for the first success, and the probability is going to stay the same for each one. Probability is going to be P. All right, so all we need to know is the number P, and that's it. All right, so geometric probability, the probability of the first success taking place on the xth trial is, the probability of success on any given trial is P, is 1 minus P to the x minus 1 times a P. So this is the probability of failure, and this is the number of failures that are going to come before this last success. All right, there is a built-in geometric PDF, and there's a geometric CDF. The PDF, it really isn't worth using. The CDF, yeah, we can use that, but the PDF, not really a point. So CDF would be, we'll talk about it later, but on or before a certain trial. PDF is exactly that trial. So Mr. Robeson makes 30% of the 45-yard field goals he attempts. What is the probability that the first 45-yard field goal he makes is on his fourth try? So we've got P equals 0.30. We're asking about the first success being on the fourth try. All right, we have two options. I can make or miss. Trials are independent. We're looking for the first success on my fourth try. The first one he makes. See, there's the first. Yep. And the probability stays the same. All right, so this is geometric. We're asking exactly about the fourth. All right, so what we would do is we'd say this is, so if this is success, then failure would be 1 minus 0.30, which would be 0.70. So we're going to have that happen 3 times. So it's going to be 0.70 to the third. And then on the fourth try, we're going to get this success 0.30. And that's going to give us our answer. All right, oh, turned off. So we're going to have 0.70 raised to the third out of the exponent times 0.30. And that gives us 0.1029. And that's how geometric works. All right, if we want to find the mean or the expected value, really it's more expected value here, it's 1 divided by P. If we want to find the standard deviation, it's the square root of the probability of failure, 1 minus P, divided by P. So the mean for this geometric, how many tries it will take me to make my first one, would be 1 divided by 0.30. And the standard deviation of, if we did this over and over again, how many tries it would take me to get to my first success would be square root of 1 minus 0.30 over 0.30. All right, so let's see. 1 divided by 0.3 is 3.33333. And the square root of 0.70 out of the square root, arrow over to get out, divided by 0.30 is 2.7888, or 2.79. So we get 3.33, 2.79. All right, so this also makes me think, since it can't be less than 1, and that's a pretty large standard deviation, if I subtract that from that, I'm getting less than 1 already, that it's definitely going to be skewed to the right, because it can't go left. It can't go past 1. All right, so we'll see a graph of that in a minute here. So suppose we have a giant tub of thousands of Skittles so that the trials can be considered independent. Remember, if the population is more than 10 times the sample, or the sample is less than 10% of the population, we can do that. And each color has a 1/5 chance of being selected. What's the probability that the first yellow Skittle selected will be on the 6th try? All right, so we're asking for the first. This tells me it's geometric. Probability of success, or the probability of yellow in this case, is 1/5. So that means the probability of failure is 1 minus 1/5, or 4/5. And we're asking about the 6th try. So that means we're going to have 5 failures and then 1 success in that exact order. That's why we don't have that extra number out in front like we did for binomials. So we get, let's see, I can change these to decimals if I want, 0.8, 0.2. So we'll have 0.8 5 times a 0.2. And that should give us our answer. All right. On the AP exam, writing out this formula counts as showing it's geometric, or you can write out geo, that's fine, or geometric, something like that. We'll say that it's geometric, and that is enough to give you geometric points. Even if you write out geometric, if it's geometric and do everything else wrong, you might get partial credit still for points. All right, same scenario. What is the expected number of trials needed to get a yellow Skittle? All right, so all we need is P, because it's geometric. We're looking for the first success. So the expected number of trials to get our first Skittle is 1 over 1/5. That's our P down there, which will give us 5. Boom, done. All right. What about the standard deviation? Well, our P is still 1/5 or 0.2. So we get that the standard deviation is the square root of 1 minus 0.2 over 0.2. Then we're just typing that in our calculator. We can type in the square root of 0.8 divided by 0.2 if we want. Where's my calculator? Second square root 0.8 out of the square root. Don't forget to arrow over, divided by 0.2. Imagine if you make a mistake, it's because you're going to forget to arrow over, like you're going to do this. You're going to type in 0.8, and then you're just going to type divided by 0.2, and notice it's all under the square root there, and it's going to give you the wrong answer. All right, so we get 4.47, which is option C. There it is. All right, so more on geometric. So now we're looking at the on or before instance here. It's kind of like the less than for binomial ones. So we can do the CDF here. This is probably easier than adding up all the different ones, but you know, it's up to you. So we're playing some sort of game where a student has to guess the day of the week that another student is born. The probability of success for this game is 1 in 7, since there are 7 days in a week and only one of them is going to be correct. And trials are independent because we're going to switch kids every single time. We're going to go around the room and say, what's this person's birthday? What's this person's birthday? What's that person's birthday? All right, so that means they are going to be independent. So B, I, F, S, those all work out because we're looking for the first guess. So this is geometric. We're asking about the first being corrected on the 4th try. Well, our probability of success is 1/7. So that means our probability of failure, 1 minus that, is the other 6 days, 6/7. So that means we're going to have 3 failures and 1 success. So we're going to have 6/7 to the 3rd times 1/7 as our answer. All right, so our calculator, not too far. Parentheses, 6 divided by 7 raised to the 3rd out of the exponent times 1 divided by 7. Or I could have just put divided by 7 here, but that's fine. 0.0899, so about 0.09. Oops, too far. 0.09. All right, now what about the probability that the student's first correct guess is on or before the 4th try? So that means they could get it on their 1st try, their 2nd try, their 3rd try, or their 4th try. So we could find each of these probabilities and add them up, which isn't too hard. I mean, there's only 4 of them, but it's actually much easier if we just go into the geometric CDF with, let's see, it's P is we just wrote it as a fraction, 1/7, and X here is less than or equal to 4, like that. So if we go into the second VARS menu, same as place as all the probability stuff is, and it's the very last one, geometric CDF. Our P is 1/7, 1 divided by 7. Our X value, I believe, was 4 on or before the 4th try, and 0.46. There we go. What is the probability of the student's first guess is on or before, first correct guess, there you go, on or before the 7th try? Well, since it's saying on or before, That means we're still using the CDF. Our P is still 1/7. Our X here is on or before the 7th. And we get, well, here's the shortcut. Second, enter. I'm just going to change, all I have to do is change this to a 7. Voila. 0.66. All right, that's how we do it. We could find the expected value of the standard deviation here too if we wanted to. The expected value is actually, I think it's going to be 7, but well, I think maybe we'll see that later. All right, so here's our distribution. Notice our distribution. It starts high and always gets lower. It's always going to be that way. The first trial is always the highest. So the first trial always has the highest probability, and it's always heavily skewed to the right with geometric. All right, because each time the probability is going to get a little smaller, a little smaller. All right. So our shape is skewed right. Our center is our expected value is 1/1/7. In this case, it's going to be 7. So our center would be here, right? No, here. 6, 7. Yeah. So our center is here at 7. So half the data is below. I guess it's not the median, it's the mean. All right. And our spread, our standard deviation is the square root of 1 minus 1/7 over 7. No, not over 7. Over 1/7. There we go. All right, so we got the square root, second square root of 1 minus 1 divided by 7 out of there, divided by, parentheses, 1 divided by 7. And we get 6.48. All right, so like one whole standard deviation brings you to there. All right, so one whole standard deviation, one whole standard deviation, one whole standard deviation. Yeah, it just keeps going off to the right, but it doesn't go off to the left, so it's definitely skewed to the right. All right, and that is it for geometric. All right, so that is everything we need to cover for first semester, all probability stuff. Next up would be, well, next up is a test. And then we'll start in January with sampling distributions and all sorts of other fun stuff. And inference gets so much more fun in the second semester. All right, I'll see you later. Bye.